Hello, everyone, and it's my pleasure to be the first speaker here. And I come from eSurvey, and I'm the general manager. I'm Maxima. Next, I will introduce our new technology and the products, and also the company introductions as well. So first, I will play a video to show where we come from and introduce our company.
Mountain. Mountain.
Yeah, it's working well.
Mountain. Bridge. Lake. Road. Farmland. City. It is not merely a matter of beginning anew. Rather, it is about building upon the foundation of giants and consistently surpassing my own limitations. eSurvey will always behave and think in the same manner as we did when we first met. We are always together, solving problems and sharing joy. eSurvey, focus on precision and reliability.
Yeah. So the company was established in 2005, and we started to join INTERGEO from 2018, and from every year we come here. We focus on satellite navigation technologies and serving in the geospatial information and infrastructure industries. So we get now expanding the business for more than 100 countries and have more than 50 product lines and serving about 15 industries solutions. And now we have, based on the 20 years of the research and development, get the single unit is more than 500,000 units globally, and we are focusing on the product qualities and try to dig inside the user's needs and improve it. So the customer service we are doing is globally, like in German, we have a subscription. We have an office and in Brazil as well. So we are proud of our product quality. Our statistics show the first year yield rate is about 99.7%. And here is something we got. The patent we got globally is about 220, and our staff is all professional, and 40% is graduated, and 90% undergraduate. So the average year of the company is about 31 years old, and we are both the patient and also a professional team. Focus on precision and reliability. That's what we insist on. So we do the innovation, and we do the insist on the make the product reliable, quality, and the precision. So now is we located in China, in Shanghai, the headquarters there, and we have Brazil and the German office to serve globally. So here is what we are exactly doing, the product portfolio. The GNSS receivers, you see the RTK receivers, and the laser series product, airborne and the mobile, the boat, and the car carried LiDAR scanning products and the monitoring solutions, including both the cloud platform and hardware sensors together, and the cost solutions, also including the hardware, software, and service. And we also do the optical surveying equipment, antenna, radio, machine control systems, and also the agriculture, marine surveying, and for the mobile P-box and those kind of box thing. So this is what we are doing. And today, actually, I'm focusing on the LiDAR scanning technologies that those years after our research and dig inside the requirement of the industry, I would like to see real time is the trend of the LiDAR scanning. So the problem or the development is actually stopped by the post-processing of the point cloud. A lot of people to collect, to capture the data is quite easy, but to get the data post-processed by days by day, and also the failure rate is quite high. So this based on those kind of research, and we develop the real-time technologies. So we focus on to the real-time point cloud. So next, I will mainly explain how we did to realize the real-time for the point cloud SLAM, mainly SLAM product. So we do the real-time and mainly to realize the real-time colored point cloud, real-time high-density, high-quality point cloud, and real-time to do the data verifications, which means we can detect if the data is qualified or not in field. We don't need to go back to the office and to say, I have the picture didn't catch, I have a black area that I need to go back to the field again. And also, we don't need post-processing. So we directly export the data to the final result that you can use directly. So I will explain here is a video of the product that we have developed. It's eScan M1. It's a very light and small product that easy to use for the for some real-time needed scenario. So the data is showed in the mobile phone screen that you can see is colored in the field. And by the real-time point cloud, the density is 4 times of the regular way. And what you see in the mobile screen is what you get in the computer, just to export to the computer and ready to use the point cloud. So I will explain a little bit deeper of how to get the real-time colored point cloud. So first, we know SLAM technologies, they have two most important sensors. One is the laser sensor, the other is the visual sensor. And the laser visual, most of the times is working in parallel. They don't affect each other. So we do the real-time capturing the data and cross the processing in the middle. I mean, when you do the collection, it's calculating. So for example, the environment it's blocked by the laser. Laser is blocked somewhere, something behind, and the laser will miss the data. So we'll use the camera to catch the feature point, the colored point, to give the compensate to the distance measurement. And also for the environment like very dark or very light, the feature point is not so obviously. So this time, the laser sensors will give the compensate to the featured to the visual sensor. So by this real-time calculation, we are easy to get the colored point cloud in real time. And also we do the FPGA optimizations. We upgraded the processor hardware mainly in the hardware itself. So we do the edge computing. So the edge computing will allow you to process the data in real time. And we optimized the algorithm, use the FPGA optimizations. So the data reading and data processing happened at the same time. And we also do self-develop the data format. This is when we do really the real-time processing, the data come and you need to read the data and you need to write the data, you need to process the data, and there are multi kind of data come together. So the positioning data and the IMU data and the image data, so to process them together, and we do the data structured and to seamlessly data processing and storage to be happen together to save the time. And also innovationally optimize the petrol filter. So based on the environment, we segment we segment the data by the wall, or the group the data by a wall and maybe the ground. And if the environment is very complex, we will just collect more data. And if it's just the same wall, that's the same color, we will capture less data to improve the processing time. That's why we can get the real-time point cloud. And it can be seen in the mobile phone. So the computing, the edge computing is finished in the hardware this way. And the second is we did the high quality point cloud in real time. So we do tried a lot of methods to store the data. Like at the very beginning, we tried the SD card, and then use the class 10, and finally we stopped by the eMMC storage hardware. This way we can keep 80 megabyte per second. And we know the storage and to process the data, you will always write and read the data. So only in this way we can keep stably. We have 80 megabyte per second, and we use this method. We also have 30 megabyte per second exporting exporting speed. So we do the we do the exporting and some traditional device, they will do the post-processing, and we just export it. So the whole workflow will save a lot of time to get the result. So, for example, around 1 hour data capture, we have about 60 gigabyte data, and we will have just 3 minutes to export. And the biggest feature is always related to the customer needs. So we do the display. I mean, the display algorithm in real time in the mobile phone. We do the precision segmentations to do the batch rendering. So this way, we don't rendering in for the screen every point. That's not possible, and that's a big requirement for the hardware, and the cost will be high. So we do these precise segmentations to do the point rendering. And the millisecond level of the latency to real-time displayed in the mobile screen. This way, you are just to zoom in the screen and see is there some point that the color is not ideal, or is there some point missing. So this way I will check to zoom in, and I will check. I will do a picture or scan the particular area again. So, sorry? Yeah, so I will give you a picture of the last step of the data exporting. So we have around 300 megabyte per second data output. And while the traditional way is that always processing the data, and you will see this figure and feel sleepy, and you can sleep a little while, maybe next day. For example, 8 hours data, the processing or the exporting traditionally will need 4 hours, and we'll have 3 minutes. And there's 21 seconds left, and looks good. For 30 minutes left good, you can do something else. And so zero post-processing is ready to use point cloud result. That's our features. And beyond of M1, we have a series of the product for eScan series. M1 is what I'm talking about today, and we have M3 and M5. So a little bit different between each other. Oh, here's the M1. 2 minutes. Okay. It's very light and multi-mounted possibly. So we have a carry shelf, and also have a backpack, and also put a hammer that you can wear when you go to a terminal that need your 2 hands free. So last part. So we upgraded for M3 that upgraded the panoramic cameras for more colored, and it's good for the Gaussian modeling. And we have the M5 will be the next one. So it's a longer range and a faster scanning speed. Last is welcome to our booth. So under the first floor. And we have our booth is in the same hall and the first floor, C030. And welcome to there. We can communicate more if you are interested in. We have other products as well. And thanks. That's what I can see today. Thanks a lot.